Classical elements typically refer to the concepts of earth, water, air, fire, and then ether, which were proposed to explain the nature and complexity of all matter in terms of simpler substances. Ancient cultures in Persia, Greece, Babylonia, Japan, Tibet, and India had similar lists, sometimes referring in local languages as air or wind and the fifth element as vacuum. The Chinese system lists wood, fire, earth, metal, and water, although these are described more as energies or transitions than material types. These different cultures and even individual philosophers had very varied explanations about their attributes and how they related to observable phenomena as well as cosmology. Sometimes these theories overlapped with mythology and were personified in deities. Some of these interpretations included atomism, the idea of very small, indivisible portions of matter, but other interpretations considered elements as divisible into infinitely small pieces without altering their nature. While the classification of the material world in ancient India, Hellenistic Egypt, and ancient Greece into air, earth, fire, and water was more philosophical, during the Islamic Golden Age, medieval scientists from Middle East researchers used practical and experimental observation to classify materials. In Europe, the ancient Greek system of Aristotle evolved slightly into the medieval system, which for the first time in Europe was subject to experimental verification in the 1600s, during the scientific revolution. Modern science does not support classical elements as the material basis of the physical world. The atomic theory classifies atoms into more than 100 chemical elements, such as oxygen, iron, and mercury. These elements form chemical compounds and mixtures, and under different temperatures and pressures, these substances can adopt different states of matter. The most commonly observed states of solid, liquid, gas, and plasma share many attributes with the classical elements of earth, water, air, and fire, respectively, but these states are due to the similar behavior of different types of atoms at levels of similar energy, and not because it contains a certain type of atom or a certain type of substance.